In Module 4, we looked at testing differences between means. Today, we're looking at a regression analysis, which is a statistical process that allows you to examine the relationship between two or more variables. It quantifies a continuous relationship between a dependent and an independent variable. The dependent variable is a variable being measured in an experiment, and it is dependent on the independent variable. The independent variable is a variable that is assumed to have a direct effect on the dependent variable. In today's module, we're looking at the chirping behavior of crickets to see if the chirping frequency changes with temperature. So the dependent variable is the chirping frequency, and the independent variable is the temperature. As before, let's start by going to the Data tab. Go up, click on the Data tab, and once you have that up, go down and select Regression. The next step is to identify the range. The Y range is the dependent variable, which in this case is the chirping frequency. So go ahead and select the data for the Y-axis first. The next step is to identify the independent variable, which is the temperature. Select that, make sure you check labels, new worksheet for an output, and also check residuals. And click OK. And here you have your results. So now I'm going to explain the results so you know what the output means. You don't need to know every part of this output. The first step is to look at the overall regression accuracy. This can be determined by looking at the R-square. R-square represents the percent of variance of the output variable, which in this case is the chirping frequency, that is explained by the variance of the input variable, which is the temperature. So here we can see that the R-square is 0.697, which means that 69% of the variance of the output variable is explained by the variance of the input variable. The next thing we'll look at is the probability that the output of the regression is not by chance alone. Here the significance is 0.0001, so the probability that this relationship is by chance alone is less than 0.01%. This means that we accept the hypothesis that the chirping behavior of crickets is dependent on temperature. Finally, we look at correlation analysis. Correlation is very similar to a regression analysis, except there is no prior notion of an independent or a predictor variable. The analysis simply quantifies the trend between two variables with a value called a correlation coefficient, or R, which ranges between -1 and 1. The closer the R value is to -1, stronger the negative trend between the two variables. Closer the R value is to +1, stronger the positive linear trend between the two variables. When R is around 0, there is little or no linear trend, and a scatter plot of the two variables in this case would look like a random collection of points. In the data set here, we're looking at a correlation between conductivity and sulfate concentrations for a bunch of streams. So to run a correlation analysis, as always, make sure you label your cell. Go up, identify the cell, write correlation, move down, select your output cell, then go up, write equal, correl, open parenthesis, select the range. Remember, in this case, the order does not matter, so we are first selecting conductivity and comma, and your second variable, which is sulfate. Go down, close parenthesis. So your correlation is 0.98, which shows a strong positive correlation between variables. Regression and correlations, a scatter plot is the best way to visually represent the trends. So go up to a scatter plot. Here, go up to change data type. Remove all of the variables because you want to control what you're putting into the data set. Identify, hit add. Then your X range is conductivity. Select the data. Then your Y range is sulfates. Identify the range, select it, check OK. And now here's your output. You can see a positive correlation, but what you'd like to see is a trend line. Go to Add Chart Element, go down to Trend Line, and choose Linear Trend. And there it is. And you can see a strong positive relationship between the two variables.